Beneath Manila Bay, 30 kilometers below the seafloor, a fault zone stretches for 1,200 kilometers. It hasn't moved in over 500 years. When it does, it could generate a magnitude 9.0 earthquake and a tsunami that reaches Metro Manila in 20 minutes. 13 million people live within the impact zone, and most have no idea this threat exists. This is the Manila Trench, the Philippine megathrust, and it's the most dangerous fault system you've never heard of. When people think of earthquake threats to the Philippines, they think of the Marikina Valley Fault, the big one, the magnitude 7.2 earthquake that could destroy Metro Manila. But there's a bigger threat, a much bigger threat. The Manila Trench, also called the Philippine Trench in some sections, is a megathrust subduction zone. The same type of fault that caused the 2011 Japan tsunami. The same type that caused the 2004 Indian Ocean tsunami that killed 230,000 people. And it runs directly offshore from Metro Manila, central Luzon, and the entire western coast of the Philippines. Unlike the Marikina Valley Fault, which sits on land, the Manila Trench is underwater. When it ruptures, it won't just shake buildings. It will displace billions of tons of water, and that water will come crashing toward Manila Bay in a massive tsunami. FIVOLTS has been warning about this for years, but the threat is so massive, so catastrophic, that it's difficult for most people to comprehend. Today, we're going to uncover the Manila Trench, what it is, why it's so dangerous, when it might rupture, and what a magnitude 8 or 9 earthquake and tsunami would mean for Metro Manila and the Philippines. The Manila Trench is a subduction zone, a place where one tectonic plate dives beneath another. On the western side of the Philippines, the Sunda Plate, part of the Eurasian Plate system, is being pushed beneath the Philippine Sea Plate. This process, called subduction, happens along the Manila Trench. The trench itself is an underwater valley stretching 1,200 kilometers from Luzon to Mindoro to Palawan. At its deepest point, it plunges more than 5,400 meters below sea level. But the real danger isn't the trench itself, it's the fault interface, the zone where the two plates meet, 20 to 40 kilometers beneath the sea floor. This is where stress accumulates, where the plates lock together, building pressure for decades, centuries, or even millennia. And when that interface finally slips, it releases energy equivalent to thousands of atomic bombs. The seafloor above the fault suddenly shifts, rising or dropping by several meters in seconds. That vertical movement displaces massive volumes of water, and that displaced water becomes a tsunami. This is how the 2011 Japan tsunami happened. The Pacific Plate subducted beneath Japan, the fault ruptured, the seafloor rose 10 meters, and a 40-meter tsunami struck the coast 30 minutes later. The Manila Trench works the same way, and it's capable of producing the same result. The question isn't if it will happen. The question is when. Here's the terrifying part. We don't know when the Manila Trench last ruptured in a major earthquake. There are no written records of a massive megathrust earthquake along the Manila Trench in Philippine history. Not during Spanish colonization, not during American rule, not in modern times. But geological evidence tells a different story. Scientists have found tsunami deposits along the coasts of Luzon, layers of sand and debris that could only have been deposited by massive waves. These deposits suggest that major tsunamis struck the Philippines in the past, possibly 500 to 1,000 years ago. But without precise dating, we can't know for sure when the last major Manila Trench earthquake occurred. And that's the problem. Megathrust faults like the Manila Trench operate on cycles. They lock, build stress over centuries, then rupture catastrophically. The longer the fault stays locked, the more energy accumulates, and the bigger the eventual earthquake. In Japan, the fault that caused the 2011 tsunami had been locked for about 1,100 years. In Sumatra, the fault that caused the 2004 Indian Ocean tsunami had been locked for about 500 years. The Manila Trench, we don't know, but if it's been 500 plus years since the last major rupture, the accumulated stress is enormous, and the next earthquake could be catastrophic. FIVOLTS estimates the Manila Trench is capable of producing a magnitude 8.0 to 9.0 earthquake. For reference, the 2011 Japan earthquake was magnitude 9.1. The 2004 Indian Ocean earthquake was magnitude 9.3. We're talking about the same scale of disaster, but this time it would happen just offshore from Metro Manila. Let's walk through what a Manila Trench megathrust earthquake would look like. The rupture would begin 30 to 50 kilometers beneath the seafloor, somewhere along the Manila Trench offshore from central Luzon or Metro Manila. Within seconds, the rupture would spread along the fault, potentially for hundreds of kilometers. If the entire Manila Trench section ruptured at once, the earthquake could reach magnitude 9.0 or higher. If only a segment ruptured, it might be magnitude 8.0 to 8.5. Either way, it would be one of the strongest earthquakes in recorded Philippine history. In Metro Manila, the shaking would last 3 to 5 minutes, not the 45 seconds of the 1990 Luzon earthquake. 3 to 5 minutes of violent rolling motion. Buildings would sway. Older structures, especially those not built to modern codes, would collapse. Bridges would crack. Roads would buckle. Power lines would snap. Gas lines would rupture. Fires would break out. But the shaking would only be the beginning, because this earthquake wouldn't just shake the ground, it would move the seafloor. The fault rupture would cause the seafloor above the subduction zone to shift vertically, rising or dropping by 5 to 10 meters in seconds. That movement would displace billions of tons of water, and that water would have to go somewhere. Within minutes of the earthquake, a tsunami would form. The displaced water would radiate outward from the rupture zone in all directions. Some of it would head west, toward mainland Asia, but most of it would head east, directly toward the Philippine coast. Depending on the rupture location, the tsunami could reach the coast of Luzon in 15 to 30 minutes. For Metro Manila and Manila Bay, the timeline would be terrifyingly short. Manila Bay is a shallow, semi-enclosed body of water. This is the worst possible geography for a tsunami. The bay's shape would amplify the wave, funneling it toward the densely populated coastline. FIVO-LCS has run tsunami simulations for a Manila Trench earthquake. The results are catastrophic. A magnitude 8.5 earthquake could generate a tsunami 5 to 10 meters high by the time it reaches Manila Bay. That's 15 to 30 feet of water crashing into the coastline. A magnitude 9.0 earthquake could generate a tsunami 15 to 20 meters high. That's 50 to 65 feet, the height of a 5-story building. The tsunami would strike low-lying coastal barangays first. Areas like Navotas, Malabon, Tondo, and parts of Pasay and Parañaque would be inundated within minutes. The water would surge inland, flooding streets, homes, and buildings. Cars would be swept away. Structures would collapse under the force of the water. The wave wouldn't stop at the coastline. In low-lying areas, it could penetrate several kilometers inland, especially along river channels and drainage systems. And unlike a flood, a tsunami doesn't just rise slowly. It hits with immense force, like a wall of water moving at highway speeds, carrying debris, vehicles, and entire buildings with it. The tsunami would also affect other coastal areas along western Luzon. Bataan, Zambales, and Pangasinan would all face inundation. Depending on the rupture location, southern Luzon and even parts of the Visayas could be impacted. In total, millions of people along the western Philippine coast would be at risk, and most would have less than 30 minutes to reach high ground. For many, that wouldn't be enough time. Metro Manila is uniquely vulnerable to a Manila Trench tsunami for several reasons. First, population density. Metro Manila is one of the most densely populated urban areas on Earth. More than 13 million people live in the metro area, and millions more live in surrounding provinces. Coastal barangays like Navotas and Malabon have some of the highest population densities in the country, more than 20,000 people per square kilometer in some areas. Second, low elevation. Much of coastal Metro Manila sits barely above sea level. Some areas are even below sea level due to land subsidence caused by groundwater extraction. This means a tsunami doesn't need to be massive to cause catastrophic flooding. Third, poor infrastructure. Many coastal communities are informal settlements with structures that aren't built to withstand flooding, let alone a tsunami. Roads are narrow, drainage is inadequate, there are few designated evacuation routes or tsunami shelters. Fourth, lack of awareness. Most Filipinos know about the Marikina Valley Fault and the big one, but far fewer know about the Manila Trench. Tsunami awareness in the Philippines is low compared to countries like Japan or Indonesia, which have experienced major tsunamis in recent decades. Fifth, limited warning systems. The Philippines has a tsunami warning system operated by PVOLCS, but it relies on detecting earthquakes and issuing warnings. For a Manila Trench earthquake, the tsunami would arrive so quickly, 15 to 30 minutes, that there would be very little time to evacuate coastal areas. Even with a perfect warning system, many people wouldn't make it to safety in time. Finally, economic impact. Metro Manila is the economic heart of the Philippines. A tsunami that floods large sections of the metro would devastate not just lives, but also the national economy. Ports, businesses, government offices, and critical infrastructure would be destroyed. The recovery would take years, possibly decades. PVOLCS has estimated that a magnitude 8.5 Manila Trench earthquake and tsunami could kill tens of thousands of people. A magnitude 9.0 event could kill hundreds of thousands. The economic damage would be in the hundreds of billions of pesos, and the long-term impact on the Philippines would be incalculable. The terrifying truth is, we don't know. Mega-thrust earthquakes are difficult to predict. We know they happen on cycles. Stress builds, the fault locks, and eventually it ruptures, but we don't know exactly when. In Japan, scientists knew the fault offshore from Tohoku was capable of a large earthquake, but they didn't expect a magnitude 9.1. The earthquake in 2011 was much larger than anyone predicted. In Sumatra, there was no warning before the 2004 Indian Ocean earthquake. The fault had been quiet for 500 years. Then it ruptured without warning, generating a magnitude 9.3 earthquake and a tsunami that killed 230,000 people. The Manila Trench could rupture tomorrow, or it could stay locked for another 500 years. We simply don't know. What we do know is that the fault is active. Stress is accumulating, and the longer it stays locked, the more energy builds up, and the bigger the eventual earthquake will be. PVOLCS has placed the Manila Trench on the National Earthquake Hazard Map as a major seismic threat. The government has conducted tsunami drills in coastal areas. Evacuation plans exist, at least on paper. But the reality is that most people living in Metro Manila's coastal barangays don't know about this threat. They don't know they're living in a tsunami zone. They don't know what to do if an earthquake strikes offshore. And when the Manila Trench finally ruptures, and it will, tens of thousands, possibly hundreds of thousands of people could die. The Manila Trench is a natural hazard. We can't prevent it from rupturing, but we can prepare. Here's what needs to happen. First, awareness. The government, media, and educational institutions need to educate the public about the Manila Trench and tsunami risk. Most Filipinos have never heard of it. That needs to change. Second, warning systems. The Philippines needs to invest in early warning systems, not just for earthquakes, but specifically for tsunamis. Japan has a system that can issue tsunami warnings within minutes of an earthquake. The Philippines needs something similar. Third, evacuation infrastructure. Coastal communities need designated tsunami evacuation routes and shelters. High ground needs to be identified. Buildings that can serve as vertical evacuation structures. Tall, strong buildings where people can flee if there's no time to reach high ground need to be designated and reinforced. Fourth, building codes. Coastal structures need to be built or retrofitted to withstand both earthquake shaking and tsunami inundation. This means stronger foundations, reinforced walls, and elevated ground floors. Fifth, drills. Regular tsunami drills need to be conducted in at-risk areas. People need to know what to do, where to go, and how much time they have. In Japan, tsunami drills are routine. They save lives. The Philippines needs the same culture of preparedness. Sixth, land use planning. Building dense residential communities in tsunami zones is a disaster waiting to happen. Coastal land use needs to be reconsidered. High-risk areas should be designated as non-residential or low-density zones. Finally, research. Scientists need to study the Manila Trench more intensively. We need to know when it last ruptured. We need to understand its rupture cycle. We need better models of how a tsunami would behave in Manila Bay. All of this requires investment. It requires political will. It requires public awareness and engagement. But the alternative is waiting for the Manila Trench to rupture without preparation. And when that happens, the death toll could be unimaginable. The Manila Trench is one of the most dangerous earthquake and tsunami threats in the Philippines, and most people have never heard of it. It's a megathrust subduction zone capable of producing a magnitude 8 to 9 earthquake. It sits just offshore from Metro Manila and central Luzon, and when it ruptures, it will generate a tsunami that could strike the coast in 15 to 30 minutes. Millions of people live in the impact zone, and most are completely unprepared. We can't predict when the Manila Trench will rupture, but we know it will. Megathrust faults don't stay locked forever. The stress is building, and one day, maybe tomorrow, maybe in 100 years, the fault will slip. When it does, the Philippines will face one of the worst natural disasters in its history. The 2011 Japan tsunami killed 18,000 people despite Japan's advanced warning systems and preparedness culture. The 2004 Indian Ocean tsunami killed 230,000 people because no warning system existed. The Philippines is somewhere in between. We have some systems, some awareness, but not enough. If the Manila Trench ruptures tomorrow, tens of thousands of people could die. Maybe more. But it doesn't have to be that way. If we prepare now, if we invest in warning systems, educate the public, build evacuation infrastructure, and create a culture of tsunami awareness, we can save lives. The Manila Trench is coming. The only question is whether we'll be ready. Are you prepared? If you want to understand more about the earthquake and tsunami threats facing the Philippines, subscribe and hit the notification bell. Because the more we know, the better we can prepare. And when it comes to megathrust earthquakes and tsunamis, preparation is the difference between life and death.